Today we're going to be talking about virtual data warehousing. Specifically, we're going to be featuring technology from EMC, recently acquired Greenplum database. Myself, I'm Steven Spelcy. I work for the VMware Affinity team at EMC. My focus is on helping our customers and partners better understand the technical integrations that exist between EMC and VMware.
Hi guys, I'm Ben Werther. I'm the Director of Product Management at Greenplum. And I run basically the product side of all of our product suite. That's the Greenplum database and our new Chorus product as well.
Thanks, Ben. So today we're going to be covering some topics around how to improve the time to data mine, leveraging vSphere as a foundational element in the infrastructure with EMC storage, as well as, of course, a Greenplum as the technology above it all. Now, we'll cover a little bit around what data warehousing is, understanding that data is changing in the world that we live in. There's a new emergence of a better way to manage information called the Enterprise Data Cloud. We'll talk a little bit about what's unique about the Greenplum database and how it's changing the way we manage that information as a part of the EDC. And then how vSphere can be leveraged, virtualization can be leveraged to improve the manageability and flexibility of how to deploy enterprise data warehousing. And then lastly, we'll end with a demonstration to show how we can deploy on demand a scalable data warehouse.
Mm-hmm. Great. So, from where we sit at Greenplum, we have a lot of fun working with customers around the world who have very large amounts of data. And I think one thing that's kind of emerged in that work is that, data is kind of this abstract thing, but it's also very personal. And it starts with all the things around each of us in the world today. And if you think about everything you do today, just to kind of put data in context, you have all of these things, government, medical, internet, and so on. Each one of those are companies. Each one of those has databases, has analysis it needs to do on its data. And those companies are not the end of it. Those companies work together with other companies, doing brokers, doing kind of credit lookups and analytical services, and so on. And this greater world of data is one that's changing and emerging and developing very quickly. And what we see is that, a lot of the things that people think about in terms of data warehousing and the role it plays are, the world is quickly moving to where information itself, data, is really kind of a critical asset of companies everywhere. And so what we're going to talk about today, we're not going to get deep in data warehousing because I know you guys are more interested in the kind of the VMware side of the implementation, but I want to just talk a little bit about how this change is going to affect the kind of infrastructure you need. So let's take a step back. What is data warehousing? And I know there's books about this you can buy that go into enormous depth about methodologies and practices and all that kind of stuff. At the end of the day, it's actually much more simple than people like to kind of claim. At the end of the day, it's about you take a lot of data together, and that data may be coming in all at once, it may be coming in as a continuous stream. You can do some sort of analysis on that data, and you derive something useful for your business. That could be simple reporting, it could be deep statistical models, but at the end of the day, it's about consolidating data and deriving value through some analytical activity. And it's often, increasingly about having a place that is kind of dynamic, where data growth the data warehouse is continuously evolving. It's not a single place that is ever finished. There's always data coming in, there's always more sources of data. And so the demands on the infrastructure, if you think about data growing faster than Moore's law in a lot of companies, the demands on the infrastructure are pretty extreme. And so we're seeing, people doing some very interesting things as they try to provide an infrastructure that can handle that scale of data and that kind of growth and dynamic change that sort of affect the business. So let's talk about the way the world's changing and how we tie this to data.
Well, the old data center, the past, is highly proprietary. Stovepipe applications, single server, one app, right? Highly expensive to manage, to deploy, to scale out, typically highly centralized and monolithic in nature. Lots of process, overly run with batch, essentially. And essentially, it's heavily siloed. And the data center of the future, if you will call it, the new virtual data center, or IT as a service, is based on the ability to leverage commodity resources, server, storage, networking, and be able to put that in a pool of available dynamic resources, to be able to do it in a cost-effective manner, to be highly distributed, and to foster a sense of self-service from an end user and application owner perspective.
Yeah, absolutely. And I guess a lot of what virtualization is about is exactly these themes. Well, when you think about data as well, data has the same kind of challenges. The yesterday's data warehouses had all of these characteristics that we were just sort of talking about. And I guess, where people want to go, it's really capturing a lot of what you talk about in terms of the benefits of virtualization, but applied to these systems that may have hundreds of terabytes of data. And so same kind of things apply. How do you use commodity hardware? How are you cost effective, distributed? How can I self-service create capacity for new projects, be real-time dynamic, have depth of data, and so on. And so, this is a real change that's happening right now, and we see it, across our customer base, but across the industry, where people are rethinking data. It's not about data warehouses in the old sense, it's about kind of a new kind of infrastructure. And it starts with a realization, if you guys, have ever spent any time hanging out with people who build EDWs, enterprise data warehouses, that the EDW isn't the be-all and end-all. Any company has hundreds of databases, data spread out across the organization. And so the first thing you need to do is not try to put it in one place, because that never works, but build an infrastructure that's able to handle that kind of proliferation of data in a way that's more manageable, allows you to leverage those data assets in a real way. Virtual infrastructure can help. So I want to give you a real example, because this is all very nice theoretical stuff. But this is a real example of a customer of ours, T-Mobile. And so T-Mobile is as an organization, T-Mobile, you all know from the cell phone company, like many enterprises, has a lot of investments in infrastructure. They're buying into sort of, VMware, UCS, architecture. They had Teradata data warehouses. They had a challenge, though, that they had on the data side. They had this big enterprise data warehouse that had about 100 terabytes of capacity, which is pretty big. And that thing was playing its role as a central point of governance and reporting and doing all the things that enterprise data warehouses do. But you had this business where, across the business, smart analytical people who wanted to be able to analyze and derive value for the business were kind of stymied because the data was either in the data warehouse, maybe some of that data they needed. The rest of it was spread out across, silos where the cell tower data was being aggregated, and silos where maybe clickstream data was being aggregated from phones. Marketing data was over there. There was no place where it all went. And so what they found was, when they wanted to ask really simple business questions, for example, particular question was, why do people churn and leave T-Mobile to go to a different cell phone company? And they had theories, but they had no way of combining the data to figure it out. And that EDW itself, while being a good place for some of the data, was only about a tenth of the size of all the real data they needed to analyze to kind of answer that kind of question. But being this proprietary, heavy Teradata mainframe, there was no way they were going to make that thing grow to handle all the kind of new demands. And so they realized that they needed a different kind of infrastructure. And they actually came up with this term at about the same time we came out with the same term of enterprise data cloud. It's funny, this term kind of started coming up in a few different places. But the idea was not to build a bigger, better EDW, because that just doesn't work. We've seen that fail many times. It was to provide a new kind of infrastructure where they could break down the walls between the silos. They could provision capacity. So next time a project comes along, or next time there's a data source that's interesting, they can provision capacity out of this infrastructure. They can load the data up in there, and then they can treat it more like a service utility. But then they can actually bridge the data, use the capabilities of Greenplum database and what we're now calling Chorus, to start kind of breaking down the physical walls between the different data silos, and allow analysts to explore and combine data from across all these sources. So what really happened? So the first system we put in there, they had this 100 terabyte system. They bought a petabyte from Greenplum, which is a pretty big system. In the first 2 weeks, they started pulling a few sources together, provisioning capacity, pulling some sources together, and they combined cell tower data with some relationship data of different users, people who are your friends and family, essentially, and some other types of data that might be interesting. And they had two theories they wanted to test. One, how does core quality affect your likelihood to stay? And two, how does your friends and family affect your likelihood to stay? And so in 2 weeks with this new system, they were able to do something they'd never been able to do before, which was they ran the statistical correlation on the core quality, and it came up with no correlation, no real effect from core quality on their likelihood of you staying or leaving. Then they ran the correlation with the friends and family network, and they saw that you were 7 times more likely to leave if one of your close friends and family left. And so you were actually able to model this sort of evolution of people leaving like a virus spreading through the network. And that meant there was immediately actionable things they could do to start being able to sort of stem that. And so that was the first 2 weeks. And so I think they saw this value of saying, let's stop treating this as this precious mainframe. Let's treat it as this dynamic, self-provision, self-service, kind of almost like virtualized infrastructure. And I think that's a very powerful transformation that many customers are starting to make. So what goes with this, though, is not just about the system. And I'm just going to touch on this because this is a much longer conversation, but I only want to take about a minute on this. But we came up with this new kind of way of describing a methodology that kind of goes with this. And this is something that was actually coined by an advisor to our company, a guy named Joe Hellerstein, who's a professor of databases at Berkeley. And so what he saw when we were working with him was that really there was this new way that you needed to work that really affects the way you build your infrastructure, which we called MAD skills. Stands for magnetic, agile, and deep. And so what that essentially means, magnetic means stop trying to hold back all the data and wait till it's all governed, all organized and cleansed. Just get it in. Be a magnet for data. Get all that data in. And that means you need an infrastructure that's big enough and scalable enough to be able to handle all that data, because all that data has value. Agile means, use it as a dynamic platform where you're able to create capacity on demand, you're able to do things dynamically, you're able to ingest and analyze and allow analysts to use this as an experimentation platform rather than a lockdown kind of governance-controlled platform. And then deep is about this notion that, hey, if I have got 100 terabytes in this thing, and maybe I'm agile and moving the data around and provisioning and all of this, when I want to ask big questions of this, I can't have to pull the data out and load it into a different system just to ask a question of the data. So I need to be able to push the analytics to the data, not pull the data to the analytics, which means you need a database or an infrastructure that's actually able to do parallel querying and statistics and all these things directly against the data. And so just to touch on that real quick, so magnetic, this is kind of the idea, hey, just be a magnet, get this stuff in, don't put up walls, allow people to do the things that they're going to want to do. Agile is really about this feedback loop, allowing people to get data in, allow data to evolve and become more clean over time, but don't force it to be done up front. Deep is about allowing you to go ask these kind of questions of your data, not just the traditional BI question of what happened, where, and when, but what will happen, which is kind of more of a prediction type question, and then interpretation questions, which get into kind of user behavior, how and why, and how can we do it better, which require more than slicing and dicing data, but running real kind of analytical models against data. And so that's where it almost becomes a parallel processing infrastructure you need underneath all of this. And so, here's some examples. Again, I'm not going to go into detail here, but just, beyond the BI, the basic BI stuff is important, and we all do that kind of stuff. But then there's all these other techniques. Many of these you probably have never heard of. I mean, I couldn't explain half of these to you, but I know that my statistician and analyst friends get very excited when they see this list of things, and there's more being added all the time. So deep is important. Don't just think you're going to put it in there and then pull it out and run a PHP script and do your analysis in there. You need, in some of our systems, we'll have 800 cores in parallel, running against the data, allowing people to do really powerful stuff that scales with the size of the data. How are we doing for time?
We're good.
We're good? Okay, just a quick bit about Greenplum architecture. Why can we do this? What is powerful about Greenplum's architecture in this context is that we are built using a technique called massively parallel shared nothing. And what that means is if you see there's a list of segment servers, those segment servers, which are the units of processing, you can add more segment servers, and the more you add, the greater the performance, the greater the capacity, the greater the loading speed. And it actually grows linearly. So if you double the number, you get double the performance, double the loading speed, double the capacity. Now with SAN, of course, your capacity and your computer are slightly decoupled, but the basic principle still applies. Now, what's exciting here about this is you can now build a system where you can start really small, but know that it'll grow to however big you need to get over time. And that's different than something like an Oracle Exadata, where it starts with one rack, and then at some point you think, well, okay, I want to grow, and now you realize, okay, well, I can only go up to about 16 database servers, and the whole thing stops working. So it's from a scalability standpoint, we have systems with hundreds of nodes with petabytes of data, and that's by no means a limit at that level. So then from an architectural standpoint, the servers scale horizontally with more segment servers. Data is automatically split. It's hashed across all of these. So you don't have to think about charting your data or doing anything like that. You load your data, you query your data. It's automatically broken up across all of these segment servers for maximum efficiency. And so when you scan a table, all the servers work together to scan that table. From a network perspective, we have this thing we call the interconnect in the middle, which connects all the servers together. It's a network, it's a commodity network, but it's using some smart software that manages the pipeline flow of data between these segments. So if you think about a query where I need to exchange some data between the nodes so I can do a join on a key, all the nodes may be communicating with all the other nodes at some point in time in the query execution. And we need to manage that pipelining of data where we're not waiting and blocking until that data is finished being transmitted. As it's flowing through, it's flowing into the next stage of the query, and then it's flowing into the next interconnect flow, and so on. And it's this pipeline, it's almost like water flowing as it executes through the query. And so this GNet architecture allows that to happen in a way that really fully utilizes the network as part of that. The master servers are where they receive the queries that are submitted. That could be SQL, it could be MapReduce jobs, which are programming jobs written in Perl, Python, Java, C, and others, or other analytical functions. And all of those will run in parallel across the segment servers, but you submit them up there, and it handles the dispatching of that work and returning the results to you. And then, one more. Yeah, and then the query plans that it dispatches actually encode the motion, the communication between the segments for parallel execution. So we can maximize the efficiency of that execution because we know exactly when data needs to be exchanged, and we can make sure that that's done by everybody at the same time in a way that efficiently allows them to pipeline. So we've done a lot of work to make this really scalable in a way that means you can run the full breadth of SQL and all this other MapReduce stuff. I mean, this is, we've been at it for 7 or 8 years here. It takes a long time to parallelize a lot of the depths of SQL and the more interesting stuff. Okay, and then I think my last slide here, just touching on from a key technology pillars perspective. Then what's key here about Greenplum database that makes it sort of our secret sauce. Parallel query optimizer. You got to extend your query optimizer to be able to handle parallelism, and we have an amazing team of guys who. Been around building optimizers for Microsoft and others who have been at this for the last few years. The per node execution, what we're calling our parallel data flow engine, which is handles the execution of whatever that piece is on each node as with a chunk of SQL or a chunk of MapReduce or some other analytical function, doing that very efficiently. The data movement using GNet, resilience to hardware and software failures. We'll talk about some of the VMware side of this. We actually have our own server mirroring that allows you to handle failures, but we also, in a SAN context, tie in very well with what VMware does. So we handle failures together in a way that means something fails, it'll automatically fail over to another mirror, and the thing will keep running. You'll barely see you might see a second or two of lost service, and that'll be it. And then the last one is what we call online system expansion. This also ties in very well with what we'll talk about in a minute from the VMware perspective. But as you grow the system, you're able to grow the capacity and grow the number of nodes in a way that you don't have to have downtime while it's expanding or reorganizing the data. So you can do simple things like scaling up and down capacity using some of the VMware ability to provision. We'll see some of that later. But you can also say, if I want to go from 100 nodes to 200 nodes, we did this at FINRA, which is a large, the regulator for NASDAQ and New York Stock Exchange recently. They went from 100 terabytes to 200 terabytes, and it ran in the background for a few days. They didn't even know it was expanding, but the data was all being reorganized in a way that allowed them to then scale to the next level. And so we can do some very smart stuff around growing the system without needing to take you down for weekends or weeks or any of that kind of craziness. Good.
Thanks, Ben. So the question becomes, where does this fit in to the journey to the private cloud? Where does this application find its way into this journey? We all know phase one of the journey is really more about addressing consolidation, basic consolidation in our data centers. This specifically hits in phase two, where we're talking about virtualizing production applications, mission-critical production applications that require things like massive scale, availability, protection, and of course security. If you think about it, why do we virtualize mission-critical applications? We do this because we want to guarantee the quality of service for around performance and scale, achieve higher levels of service in those areas. We want to be able to deploy and manage better, improve the time to deploy, which means improve the time to get active on a resource in our data center, in our application. We want to also, once that application has been deployed, put the best tools and technology behind it to make sure that it is secure and that it is reliable and that it is being protected both locally and remotely. So a few reasons why BI, or business intelligence and data warehousing, should be virtualized and take advantage of some of the capabilities within a virtual data center using VMware vSphere. One, scale up. So the ability to dynamically add resources to one of these running segment servers or master servers. And by the way, scale up's important, but I'd say scale out is far more important. The other ability to essentially on-demand deploy additional segment server resources, so we can do that online expansion. We can improve the load time and the query time, reduction in the response time on those queries. So it means deploying new virtual machines on demand in a Greenplum cluster to service a new load or a new requirement within a data mart. Reason three is really getting better utilization out of the resources we have in our data center. So in our reference architecture, which we have a reference link in this presentation to, we talk about leveraging DRS, we talk about leveraging clusters and ESX clusters. The ability to add a new node to spin up a set of segment server VMs, of which there'll be multiple segments on those VMs to help with that parallel processing. If we lose a node on availability, we can guard against that physical failure, spin up that new virtual server on a new node, and thus also leverage the application layer for high availability using the Greenplum software. So the two can be coupled and used together in combination, and they're not mutually exclusive. Reason five, leveraging vMotion. So as I bring more segment servers and master servers into my environment to improve my query and load time, I have the ability to move those virtual machines onto the appropriate resource to get that guaranteed response time and availability that I require, but do it in a non-disruptive manner. And of course, having the ability to leverage DRS to manage the performance and scale requirements in that cluster. If I choose to deploy my virtual data warehouse in a cluster with other mission-critical applications, I want to know that there are checks and balances in place that can move and manage resources where best suited and best needed at that time when they're required. So leveraging DRS and moving those virtual machines around within that cluster as they require additional resource. Although I would say, by and large, most customers probably leverage a dedicated cluster for VW.
Yeah, so I think, today we are a pretty intensive application. We'll really stress the machines pretty heavily. So you often want to dedicate a pool for Greenplum, but you may actually have multiple Greenplum databases using DRS or something like that, even within that pool. But this is a perfectly legitimate way of doing it, and that allows you a lot of flexibility when you deploy your infrastructure.
So it's really what all critical applications in our virtual data centers need. Really, scalability, the ability to be dynamic and flexible. Leveraging resource pools to manage performance expectations, leveraging technologies like storage I/O control to manage your service levels around how disk is consumed in your cluster. If you think about it, all of these technologies that I've just mentioned are fundamental technologies for all mission-critical applications. They require one very important thing, that's shared storage. And Ben mentioned just a moment ago that we can leverage even DAS in a model with Greenplum, and it's a perfectly acceptable solution, by the way. But to leverage all of these advanced manageability and performance-related benefits of VMware, we need shared storage. We need that to have to be high performance, and we need it to be highly available.
Yeah, exactly.
So the optimal data mart for the virtual data mart is Greenplum, vSphere, and EMC storage. On the last point on this is once we have this scalable reference architecture deployed within our data center, and we'll show you in a demo in just a few minutes, we've got a platform that can be leveraged, and essentially it's been deployed for deterministic performance and scale, and can be managed over time. And it's important to note that Greenplum databases and data warehousing databases in general, they do expand and contract. So over time, they change in their form. They're shrunk up and down. You have the ability to spin up a sandbox environment, leverage it for a period of time, and then that may be sunset at some point, right?
Yeah, and in fact, you can think about the two different axes of the data volume of any one database will generally continue to expand. But the compute you may need against it may vary with the seasons or with the time of day or things like that, which is a really powerful flexibility you get with the virtualization technology here. At the same time, you know, with that part, I forget the second part, but that's good.
You definitely have more capability than less in this particular model.
Absolutely.
Right? So some general best practices rule of thumb. When deploying in this reference architecture, we're looking at roughly 2 CPU cores per virtual machine, roughly 8 gigabytes of RAM per virtual machine. And this gives us a capability of around 300 megabytes per second of sustained throughput for the CPU and memory. Each segment server itself needs and drives up to about 300 megabytes of I/O. And it needs, in order to be successful, it needs to be deployed, the network-wise has to be deployed with a 10 gigabit Ethernet connection, or multiple 4 or more 1 gigabit Ethernet connections. And as well as the architecture, there's a public side, as you saw in the diagram earlier, and then there's a private side. So the private side is where all the segment servers communicate, and the public side communicates out to your corporate network.
And to be clear, I mean, you can start with something much simpler just to get experience and evaluate. But this is really kind of the kind of specification if you were doing something that was sort of real production grade, highly tuned for performance.
And on storage, the best practice in deployment is RAID 10 4+4, write cache enabled. In fact, leverage as much write cache as possible and disable read cache, because read cache in the Greenplum is done as a part of the
our own caching, and you do a lot of scanning, so it just gets in the way.
Yeah.
Yeah.
And that's kind of interesting because that's sort of atypical. We think of most applications, we would have to tune the cache. In this case, the application tunes itself.
Yeah, absolutely.
On the physical server space, we're looking for at least 2 physical CPUs, 8 cores, and roughly per core 4 to 8 gigabytes of RAM. Again, 2 10 gig for high availability, or 4 1 gig interfaces. That VM needs to be, again, associated with both the the master server needs to be on public and private, but the segment server can mainly be on the private. And our last really important point on storage is that it's very important that the file system that's allocated and related to the file space for the database be leveraging XFS. And this is because obviously...
Yeah, we found that XFS gives a lot more scalability. If you use like ext3 or one of the other file systems, you'll often see that you don't get that scalability because you have contention on disk. With XFS, we've had none of those problems, so it's definitely the way we recommend in our configuration.
And we're roughly seeing around 300 megabytes per second per run.
And I think the last thing to mention here is, in terms of the SAN, so using CX4, for example, a CX4 has a maximum aggregate bandwidth. As you think about the scalability of the system and building it out, you actually want to think about pods of servers plus a CX4, and maybe interleaved in a way that allows you to grow the bandwidth as well as growing the number of servers. So it's not one CX4, it's a number of, one per pod as you build up the system.
Which sort of follows a scale-out model, right?
Absolutely.
So as the database scales out, scale out your storage and your network to accommodate that.
Yeah.
So what we're showing in our demo today is based on a very fundamental use case, which is the extract, transform, and load processor, ETL. And specifically what we're showing is loading a large database and then a set of queries run against that database. Now, what we're showing you is typically what you'd see in any DW environment, where an analyst may say, hey, I've got this new project, I need to do this analysis. Let's say it's an M&A, and the CEO or the boss has said, hey, we're buying this new company. We need to do as much analytics against all the industry data, market data around that particular industry to find out if we're making a good decision. So they take all this information, they have to load it in. Loading that information, transforming it into a form in which they can leverage it takes a lot of time. So shrinking that load time improves the time to data mine. And then once you have the information in the way that it's best read and best interpreted, then you need to have the most optimal query performance to get the information out so you can use it.
And I will say that our loading performance is kind of acknowledged widely as the fastest in the industry. So just in all humbleness, it does take time, but we do a really good job of it.
I think what's interesting about this is that it's truly a linear scale solution. So as we start with a fixed number, we'll run a certain load, and then we'll run a set of queries against that. And as we move to the next set, we'll essentially double the amount of resource. You'll see that it scales linearly, and we'll triple, and you'll see that it also scales linearly.
You'll see we're loading how many rows here?
We're in one of the tables, we're loading roughly 12 million rows. Okay. But by no means is that the largest,
you can keep scaling up. We have customers with one table may have 1 trillion rows. We have many customers with tables with more than 1 trillion rows in them. So
it's always nice when your wife calls you in the middle of your presentation. So on to the demonstration. We've got in the infrastructure itself, we're actually modeling this demo against a vBlock 1, which is a joint offering from VMware, Cisco, and EMC with the Greenplum software on top. So let's take a look at the environment. Now, what you're seeing here is a set of 8 segment servers that have been deployed and 2 master servers. They've been pre-deployed, pre-configured to best practice, as I just stated in the presentation. And on tap, I have an additional 8 nodes, which I'll later add on and into the pool of available resources. And lastly, an additional 16 beyond that, making a total of 32 nodes. And what you'll see over time, as I mentioned before, we'll load the information in, and you'll see that load exponentially decrease. In this case, I've just loaded in that 12 millionth row, and that was around 41,000 milliseconds. I'm going to now run some queries against that information. And this is against the 8 node processing data against the 8 node. Take note of the queries there. Later I'll compare them, don't worry. But the time to process was a fairly short period of time using standard benchmarking type data. Now, very easily, I can go back into the virtual infrastructure client, spin up an additional 8 VMs. In this case, I've already pre-deployed them, but you can imagine me using deploy from template or orchestrator to push an additional 8 nodes and then reconfigure them for Greenplum. Now we have a total of 16 nodes running in this environment. So these 16 segment servers now processing that query. Our query was just broken down to 28,000 milliseconds, rather. Our load time, rather, was down to 28,000 milliseconds. And if we rerun the queries against that database, it's the same database that's being loaded each time. You can see that they're, again, much decreased from the first run.
And in this scenario, of course, we're reloading the data every time. You could just as easily run our expansion to grow it without having to reload the data.
And then lastly, I'm going to enable the remaining servers and bring them online and then rerun that process once again. And now once these are online, you'll see that we'll reload that information. And if we look at the last column, it's around 13,000 milliseconds. We'll run our queries against this, and in a moment we'll compare the results. So if we look, if you give me the opportunity to cherry pick, if we look at the fourth query in the 8-node environment, we're around 8,000 or 8,900 milliseconds for that query. The same query was 5,300, roughly 5,300 milliseconds on 16 nodes. And on 32 nodes, we're down to about 2,700 milliseconds. And again, this is that large query against the 12 million rows.
Excellent.
So you can see exponential scale, linear in fashion.
Yeah, and that definitely kind of matches well what we see in real life workloads, in large mixed workload environments. People are seeing effectively linear performance gains as they grow the systems. With, of course, there'll be some queries where, for whatever reason, that one doesn't quite scale on exactly the same curve, but overall we see very linear behavior.
Background information on the demo environment. This was done in our Santa Clara lab, in our Santa Clara EBC. We leveraged the vBlock 1, which is built on a CX4 platform with the UCS and Nexus IP switches, as leveraging the Greenplum database software, release 4, on Red Hat 5.5, and vSphere 4.1, which is, by the way, not officially certified on vBlock. And then, of course, we're leveraging Flare 30, which is the latest and greatest firmware for the Clarion platform, which gives you great advantages and capabilities around managing information with fast cache and fully automated storage tiering. These are new features that are available now.
Great. Yeah, thank you.
Thank you very much.
So I think just to sort of wrap up, and we'll open up for questions. I think where we started here, this little journey here, we're thinking about all this new world of data. And if you think about all of this data, the need to do compute and analysis, but do it in a way that's more agile, more flexible, we quickly get to realizing that virtualization is an ideal way to kind of enable that. And so we're very excited, all working together, now part of the same family, to build this kind of cloud-ready infrastructure, make customers successful, doing some very interesting, new, exciting things with it, using Greenplum, EMC, infrastructure, VMware vSphere, and really allow a kind of a new kind of agility and scalability that will allow new kinds of insight to be derived for business, which is what we're all in the business of at the end of the day. So thank you.
Thanks, man.
Great. Good. Any questions? Yes, please.
You said for the experiment here, turned off the cache on.
Yes, yeah, it's actually cited in the reference architecture as well. Yeah.
It's contrary to the popular belief that turning on read cache for sequential read access helps. Why is it specific to Greenplum that you recommend turning off read cache?
A couple things. One is a lot of the time will be scanned. I'm sorry. Is that? Oh, question. The question was why would we want to be turning off read cache when contrary perception is that for sequential workloads you'd want to have read cache on?
By the way, that can be done per LUN or per DAE, right? So it doesn't have to be for the entire storage array.
Yeah. And you may have your take on this too. From our side, what we tend to see is that first of all, we have our own cache buffering that's designed, it's very aware of the characteristics or type of query you're doing. If you're doing a type of big scanning operation, it'll tend to bypass cache. If it's doing something that's going to be more cherry picking, it'll use a ring buffer and be smart about how it does caching that reflects that. A lot of the big scanning operations will completely blow out the cache, and so you're basically just emptying your cache with data you're never going to come back around and see. So overall, just the experience is that it didn't help. I mean,
that's exactly what's cited in our study and the analysis we did. There was marginal improvement or effect to using read cache. So they actually, to your point, it got in the way at some point.
Yeah.
I have a follow-up question.
Sure.
If the application is caching the data blocks or data in its own buffer cache, because there are a lot of segments and there are separate nodes, would there be a situation where something that one segment requested is in its cache, but now somebody else is using it?
Yeah, so that goes to this whole idea of what MPP shared nothing. And so MPP shared nothing, every node has its own storage. That storage is completely owned by that node. That segment server, that segment has its own storage on disk, its own directories. No one else touches its directories but that segment. That means that you can have complete ownership and there's no contention down below that point, and the only communication is over the GNet interconnect. So anything it's got, it completely owns, completely private to it, and no other segment needs to know, because if it was going to receive that data, it would get it over the interconnect. And of course, that's different than something like an Oracle Exadata, where you do have locking. You have locking contention, people going for the same blocks from different pieces, and unless you tune it really well, you end up with really bad degradation as you try to scale the system.
So from the mirroring perspective, though, there are other nodes that can reconstruct. Similar to sort of like a RAID algorithm, right? Where if you lose a disk, it's
so basically we have two built-in techniques for fault tolerance. If you're using direct attached storage, we'll automatically build a mirror of that segment on a different node. So if the node fails, another node that can access that same data on its own copy. If you're using SAN, what happens is essentially if the node fails, another segment gets started and reattaches to that storage, and can use the VMware technology to do that. But then you only need one copy of the data, but you'll find another segment that can take over the same storage. Yep.
Did you have part data sets on NAS and other data sets on the VMware Pascal system?
So VMDKs, their own VMDKs on SAN versus DAS. Oh, physical and virtuals running. Yeah.
So
mixed, sort of
yeah. So best practice we've found, and this is something where we're still learning, is that the VMDK is really. I mean, the storage inside the virtual machines is great for the application. The application itself. But for the actual storage, you want to still go out directly to the LUNs and operate on them at maximum speed because you know what you own in a sense. So there's a number of ways of configuring that. I think the technique in terms of VMware there's a hybrid one, which is the one which
you're using the RDM.
Yeah.
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 There is a comment I want to make regarding that statement. You wouldn't pick RDM or VMFS if you want better performance, but there are other reasons.
Yes, of course.
Okay.
If you want both physical and virtual machines to access the data for some reason,
Yeah.
I don't know why, for some reason, then you would want.
Sure. I think it's something to understand further. I think part of the question was if we have so many nodes all hitting the same storage. But anyway, we are working on continuing to refine best practices, and we're going to definitely look forward to working more closely.
Okay, but
Yeah.
as I said, especially to answer this question, is there any situation where physical
Yeah.
and a virtual machine will be accessing the same storage?
Yeah.
The same,
Yeah.
right. Because you
The
have
other-
your own individual file space.
There's another twist on your question, though, which is interesting, is you can think about an architecture where you have it's direct attached storage on the front, a whole single, and then the mirrors are on SAN. And so in that model, you get the benefits of SAN for being able to do all of the snapshotting and things like that, but you could still have direct attach at the frontier. But these are a bunch of different hybrids that are interesting. And I think it reflects that we have really good best practices and reference configurations of the VMware ones, of course, but also some direct attached storage ones. And it's the sort of thing where if you have things you want to work with us on, we'd love to help make that happen. So.
Does the solution span all four?
Yes, it's a very good question. So absolutely, and we have a lot of interest in disaster recovery type configurations actually two different scenarios. One is a disaster recovery scenario where I just want to know that if my site goes away for whatever reason, I have another site. And we have a number of ways of doing that, particularly now being part of EMC, and in conjunction with all of this, there's some really nice techniques that are available, so we can talk about that. The other side of it is related to our Chorus product, which is really about the scenario that says, okay, well, I've got maybe a central store, but I want to now project out silos or marts or slices of that to maybe my branch offices, or I want to move data around my enterprise in a way where I can sort of have a holistic view of that and handle moving data in a kind of dynamic way. So I can schedule a transfer of this subset of data over here, maybe do a daily and do all that kind of dynamic movement of data. And that's something that's very core to the Chorus, which is not GA yet, but by sort of end of the year, that's going to be available for people to start playing with more actively. And so that's a whole new product line for us that's really around database provisioning, data services around data movement, and then data collaboration, allowing people to collaborate and find those data sources and work together to do interesting things around them. So, yeah.
There's definitely a host of infrastructure-based replication solutions that can accommodate that movement too. Like one thing that we've discussed offline is this ability to dynamically move running workloads leveraging the vPlex product, which is active storage federation between sites. Imagine, over the weekend, let's just say, because these data sets are fairly large. They're in the multiple terabytes and hundreds of terabytes in some cases. Moving virtual machines while they're running, while they're actually running analytical simulations, move them across the network. But by and large, the best practice and probably the most common implementation is all contained within. But you can imagine if you had to move a data center where this was a critical function in that data center, vPlex or Site Recovery Manager leveraging traditional replication technology would be a suitable way to go.
Yeah.
So data sets that large, what is the recommended backup?
So there's a few different ways of doing it. The way that we're beginning to work most commonly is using data domain as the backup approach. So essentially, we can do a parallel dump of the data in the database.
Or just the dump, it gets picked up.
Basically, so the idea is it does a parallel dump to data domain will dedupe it, and you'll effectively do an incremental backup automatically in that manner.
No backup application.
You would backing up to an.
You could use snapshotting. You could use
in that model, you'd back up over NFS onto the data domain, and then allow just treat it as do the dump to the parallel dump to the NFS file system, and then allow data domain to duplicate the data.
And then data domain, to his earlier question, could then replicate that to a secondary set as well.
Absolutely.
And then you could re-import that information.
Absolutely.
Yeah.
I would also think about the scenario, a lot of companies are consolidating and whatnot. They have all these silos of information and data, and they do want to pull some intelligence so they can make those business decisions. Instead of taking the time to consolidate centralized data, it's very expensive.
Oh yeah, absolutely.
It wouldn't be a product like this to centralize those data warehousing. Intelligence traffic.
Yeah. Exactly. So this idea of the enterprise data cloud that this kind of enables is one where you say, okay, I'm not going to do this sort of logical data integration, the sort of Teradata style. I'm going to spend a year debating what a customer means. Instead, I'm just going to pull the data into a place where I can now get at it with tools that allow me to do interesting things and do that quick. And so break down allow the fast provisioning, fast data movement to allow you to iterate quickly without having to get bogged down in data semantics and governance and all that.
Good. Guys, any other questions? Thank you so much for coming to the session today. Appreciate it.
Thank you very much. Yeah.
Check us out online, right on powerlink.emc.com. You can find the Greenplum, EMC, and VMware joint white paper that goes into detail on deployment, as well as greenplum.com.
Great. Thank you very much. Thank you, everybody.
Thank you, guys.